Jai Hind students. In the concept of numericals based on charge, today we are going to solve the third question. Let us see what exactly the third question is. When a glass rod is rubbed with silk so that 10 to the power 5 electrons are transferred between the two. That means 10 to the power 5 electrons are being transferred from one to another. We are asked to find out the charge on both. Let us see what would be the solution. As we know, glass rod when rubbed with silk electron transfer from glass rod to silk. ये हम लोग पहले पढ़ चुके हैं ड्यूरिंग द फ्रिक्शन. वहां हमने टेबल में पढ़ा था कि भाई गिवन अ ग्लास रॉड इज रब्ड विद सिल्क, ग्लास रॉड electrons are transferred from glass rod to silk so that glass rod is positive charge on glass rod. Let us see what will be the charge on glass rod. Qg, Q for the charge and G for the glass rod will be electron transferred. That means electrons जा रहे हैं, that means कुछ जा रहा है, that means minus. कितना जा रहा है? 10 to the power 5 जा रहा है. 10 to the power 5 जा रहा है और इलेक्ट्रॉनिक चार्ज इंटू E दैट इज माइनस 1.6 इंटू 10 टू द पावर माइनस 19 कूलम. ये फॉर्मुलेशन हमने कहां से इस्तेमाल किया? ये फॉर्मुलेशन हमने इस्तेमाल किया है बाय द क्वांटाइजेशन ऑफ चार्ज सिंस Q इक्वल टू N वाला फॉर्मुलेशन. सो वी कैन सॉल्व दैट एंड वी शैल हैव द रिलेशन और वी शैल हैव द वैल्यू. Charge on glass rod will be 1.6 into 10 to the power minus 14 coulomb. Now, charge on silk. Q सबस्क्रिप्ट S यूजिंग सेम फॉर्मुलेशन. अब यहां पर इलेक्ट्रॉन ऐड हुए हैं तो हम यहां इस्तेमाल करेंगे प्लस का सिंबल. 10 टू द पावर 5 इलेक्ट्रॉन का चार्ज हो गया, वेरी सिंपल, 10 टू द पावर माइनस 19 कूलम. दैट विल गिव माइनस 1.6 इंटू 10 टू द पावर माइनस 14 कूलम. दिस इज द चार्ज ऑन ग्लास रॉड एंड दिस इज द चार्ज ऑन सिल्क. This is the elementary numericals and very simple numerical. The next question is, what about the charge on 1 mole of electron? This question is asked in electrostatic as well as this question keeps a lot importance in the case of the electrolysis. Let us solve this. Calculate the charge on 1 mole of electron. That means, first of all, we should know 1 mole. We know that. क्या जानते हैं हम कि नंबर ऑफ पार्टिकल इन 1 मोल is Avogadro number, that is equal to Na, that is equal to 6.023 into 10 to the power 23. That means हमें जो कैलकुलेट करना है, वी आर नॉट प्रोवाइडेड हेयर, वी आर नॉट प्रोवाइडेड विद द नंबर बट वी आर प्रोवाइडेड विद 1 मोल. तो वी आर अवेयर ए 1 मोल कंप्राइजेज ऑफ दिस मच पार्टिकल्स. दैट मीन्स वी नीड टू कैलकुलेट द चार्ज possessed बाय दिस मच इलेक्ट्रॉन्स. देयरफॉर instead of therefore we should use since Q equal to Ne, we are having N equal to this much, that is Na into E Na implies 6.023 into 10 to the power 23, and E implies 1.6 into 10 to the power minus 19 coulomb. Here we have not used any of the sign. We just want to calculate the numerical value of the charge. So we can just calculate it as, doing this we get 9.6368 into 10 to the power 4 coulomb. That means Q will be equal to 96368 coulomb, which is usually used as 96500 coulomb, that is 1 Faraday. This is referred as, this is 1 Faraday. Actually this is value of 1 Faraday, and this 1 Faraday is usually represented as 96500 coulomb. So this is the fourth question, and this question is of lot importance. During the objective type question you can be asked for how much charge is in a 1 mole of electron. Well, this is one more question, that is question 5th. Calculate the positive and negative charge in a bowl containing 100 gram of water. So this question, according to this question, we are aware we are having a bowl and which contain 100 gram of water. First of all we need to calculate the number of particles. We are not provided with the number of particles of water. So we are just provided with the grams. So let us solve this. We know that molar mass of water is 18 gram. Therefore molar mass of water is 18 gram. Therefore number of moles in bowl is equal to 100 divided by 18. This is the number of moles. We know that 1 mole contain entity is equal to Avogadro number. Therefore number of molecules of water in bowl will be equal to number of moles, that is Avogadro number, into number of moles. It can further be written as 6.023 into 10 to the power 23 into 100 upon 18. That means the bowl contain this much number of water molecules. Now let us solve further. Since we can just call it to be a number of particles to be, we can place it as n. Okay, so since for in a water molecule, अब हम बात करेंगे water के molecule की. In a water molecule, water molecule has hydrogen atoms and 1 oxygen atom. Hydrogen atom has 1 unit positive charge and 1 electron. Hydrogen atom has 1 unit positive charge within the nucleus and 1 revolving electron. So positive charge 1 unit and negative charge 1 unit. 1 unit in the sense unit is electrostatic charge. While the oxygen has 8 units positive charge and 8 units negative charge. 8 यूनिट्स क्यों? 8 यूनिट्स विद इन द न्यूक्लियस, 8 पॉजिटिव का 8 यूनिट्स न्यूक्लियस के अंदर और रिवॉल्विंग 8 इलेक्ट्रॉन्स के बराबर नेगेटिव चार्ज। therefore charge on therefore positive charge possessed by water molecule। अब देखिए कितना होगा पॉजिटिव चार्ज। वाटर के मॉलिक्यूल में 2 हाइड्रोजन एटम्स हैं, दैट मीन्स मैं यहां लिख देता हूं W और प्लस पॉजिटिव चार्ज, दैट मीन्स पॉजिटिव चार्ज दैट विल बी इक्वल टू 2 into 1e, that is 1e, that is electronic charge, plus 2 we have multiplied because there are 2 hydrogen atoms in the molecule, there are 2 hydrogen atoms, that's why we have multiplied it here with 2. So 2 into 1, that is 1 into electronic charge, plus 8 into 1.6 into 10 to the power minus 19 coulomb. Now here we are just calculating the total positive charge in water molecule. So that will give 10 into 1.6 into 10 to the power minus 19 coulomb, that is 1.6 into 10 to the power minus 18 coulomb. This is the charge possessed by water molecule. This is the positive charge possessed by water molecule. I hope this part is clear. Now the total charge, now we are just calculating here that this is the positive charge only on a water molecule, only one molecule. Since we have this much number of molecules in the bowl, therefore the total positive charge in the bowl, total positive charge in bowl, that will be, we are just mentioning it as TW plus is equal to यहां जो चार्ज आप निकालोगे वो क्या होगा, Q इक्वल टू एन वाला फॉर्मुलेशन हम इंप्लीमेंट कर रहे हैं। वी हैव जस्ट कैलकुलेटेड एक मॉलिक्यूल का हमने निकाल लिया, वी हैव इतने सारे मॉलिक्यूल्स हैं बाउल में, तो टोटल पॉजिटिव चार्ज इससे मल्टीप्लाई कर देंगे। हमारा कैसे आ रहा है देखें, एन एक मॉलिक्यूल पे इतना पॉजिटिव चार्ज है और आपके पास मॉलिक्यूल्स कितने हैं, एन। तो जब आपके पास एन मॉलिक्यूल्स हैं, एक पर इतना चार्ज है, तो टोटल चार्ज कितना हो गया, एन इंटू डब्ल्यू प्लस, दैट विल गिव 6.023 into 10 to the power 23 into 100 upon 18 into W plus is 1.6 into 10 to the power minus 19 कूलम। इसे सॉल्व करेंगे तो हमें मिल जाएगा नीचे 10 1 2 1 और ये 2 हमने मैं कैंसिल कर दिया और ये 16 से कैंसिल हो जाएगा, 2 8 जा 16 और 2 9 जा 18। अब ये पूरा सॉल्व होके हो गया हमारे पास 10 to the power 2। इसे फर्दर सॉल्व करेंगे तो ये मिल जाएगा हमें this is the total positive charge in the bowl. This is the total positive charge in the bowl. Simultaneously, if we talk about the negative charge, similarly we can calculate the negative charge, or we can say, since molecule is neutral, H2O molecule is neutral, therefore the negative charge possessed by a water molecule, negative charge in water molecule is equal to, इतना ही होगा लेकिन माइनस लग जाएगा, while total negative charge in bowl is equal to, इतना ही होगा लेकिन नेगेटिव लग जाएगा, total negative charge in water bowl containing water is equal to minus 53538 coulomb. So this is the solution for the question. How can easily calculate the total charge possessed by the given amount in a container? Let us see the next question. Here we have to calculate the energy of photon which is required for pair production in million electron volt. That means we need to calculate the energy possessed by the gamma ray photon. Since we know that a gamma ray materializes to give an electron and positron during pair production. During pair production, a gamma ray materializes to give an electron and positron. That means energy is being converted into matter. This is matter. This one is electron and this one is positron. So according to mass energy equivalence relation of Einstein, we have energy is equal to mc square. This is the famous Einstein relation, mass energy equivalence relation. So since we are having here two particles, that is electron and the positron, so that means the total energy of the gamma ray will be equal to, therefore energy of gamma ray will be equal to 2 into, since this is electron and this one is positron, इलेक्ट्रॉन और पॉजिट्रॉन दोनों का मास हर तरह से एक जैसे हैं, दोनों पार्टिकल्स इलेक्ट्रॉन एंड पॉजिट्रॉन आर आइडेंटिकल, लेकिन बस इनका चार्ज अलग है, एक पर नेगेटिव चार्ज होगा और उतना ही उस पर पॉजिटिव चार्ज. Therefore we can say, here we can say this, the energy of this gamma ray photon will be equal to 2 into mass of electron या positron into c square. Now you can see here we have multiplied here by 2. Why we have multiplied it here by 2? Because there are two particles. This is because both possess same mass, therefore this is mass of electron into c square. Putting the values, 2 into mass of electron is 9.1 into 10 to the power minus 31 kilogram, and c is approximately 2 this is this way. That gives 2 into 9.1 into 10 to the power minus 31 into 9 into 10 to the power 16. Further solving, we shall have 18 into 9.1 into 10 to the power minus 15 joule. This relation gives the value in joules. So while in million electron volt, we shall convert it into million electron volt just by dividing this with 1.6 into 10 to the power minus 13. This is the value in joules. This is the relation, this is the amount of energy that is required in joules, and this is in million electron volt. We can just calculate it as this is 9 and this is 8. So that gives 9 1 ja 9 and 9 9 ja 81 into 10 to the power minus 2 million electron volt, and can further be solved as 8 1 ja 8 8 1 ja 8 8 2 ja 16 point into 10 to the power minus 2 million electron volt, or this will give 1.024 million electron volt. So this much amount of energy must be possessed by this gamma ray to produce an electron and positron pair. This is the very simplest method to calculate energy, but you can keep it memorized. For the examination point of view, because sometimes this is not asked for the calculation, but it is asked in objective type. So for the objective type question, we need to keep it memorized. Let us see the next question. The question states, calculate the frequency of gamma ray photon which is required during pair production. We know that a gamma ray materializes to give an electron and positron pair, that is energy convert into matter. This is electron and this is positron. We need to calculate its frequency. Now let us see how can we calculate that. Since according to Einstein, mass energy equivalence relation, E equal to mc square. Here the entire energy of gamma ray will convert into, or the entire energy of gamma ray will produce a electron and a positron. Therefore here E is equal to 2 mec square. Why it is 2? One for the electron and another for the positron. Since electron and positron are both identical in all respect, it must only have difference of their charges. This is negative charge and this one is positively charged. So we have because both have same mass, that's why we can use E equal to 2 mec square. Now since energy of gamma ray is given by h nu for the frequency and this symbol is for the gamma, is equal to this is according to quantum physics, E equal to h nu. So therefore we have न्यू गामा इक्वल टू 2me c स्क्वायर अपॉन h इक्वल टू 2 इंटू 9.1 इंटू 10 टू द पावर माइनस 31 इंटू 3 इंटू 10 टू द पावर 8 स्क्वायर अपॉन 6.6 इंटू 10 टू द पावर माइनस 30 solving we get this way. Now further solving 3 decimal removed and this 366 cancelled by 22 times and the 11. Now this gives 3 1 ja 3 and this is 273 into 10 to the power minus 31 plus 16 plus 34 upon 11 equal to 11 to the 22 and 11 4 ja 48 11 8 ja 88 into 10 to the power 19 hertz can further be written as nu r equal to 2.48 into 10 to the power 20 hertz. So this is the frequency which a gamma ray must have to produce an electron and positron pair. This data is to be kept memorized because it can be asked as a objective question. Let us see the next question, that is calculate the frequency of photon released during pair annihilation. जिस तरह से pair production है, in the same way there is pair annihilation, but their pair annihilation is the inverse or the reverse of pair production. That means we know that during pair annihilation an electron and positron annihilate. An electron and positron annihilate to give 2 gamma ray photons. ये दोनों मिलके 2 gamma ray photons बनाएंगे. So that's why according to this is a conversion of matter to energy. This is matter and this one is energy. So according to Einstein mass energy equivalence relation, we have the matter here. We shall use 2mec square. Why 2mec square? There are 2 particles, therefore 2 me mass of electron or positron into c square equal to 2 into E gamma. This can further be written as 2mec square equal to 2 into, this is given by h nu as per quantum physics. So quantum physics mein there is a formulation, this gives E equal to h nu. So we are using E equal to h nu, where we can mention E equal to h nu. This is the expression for frequency and this R is just to represent कि this is for gamma ray. ये R जो है represent करेगा gamma ray को. तो we can just solve it here as nu gamma equal to 2mec square upon 2 into h. That means 2 से 2 आप कैंसिल कर सकते हो, me की वैल्यू रख सकते हो 9.1 इंटू 10 टू दी पावर माइनस 31 इंटू सी स्क्वायर का मतलब हो गया 3 इंटू 10 टू दी पावर 8 का स्क्वायर और h का मतलब हो गया 6.6 इंटू 10 टू दी पावर माइनस 34 जूल सेकेंड. दिस इज प्लैंक्स कांस्टेंट and you can just solve it as 9.1 into 10 to the power minus 31 into 9 into 10 to the power 16 divided by 6.6 into 10 to the power minus 34. Solving, we can get this one decimal removed, 3, and this will be 22. So this gives 3 1 ja 3 and 3 9 ja 27 into 10 to the power minus 31 plus 16 plus 34 upon 22. This is the expression for the frequency of gamma ray which is released during pair annihilation.